So let's just back up for a moment and look very briefly. If you want us to go into more details on any of these specifics, then ask us in the Q&A, and we'll address some of the points that they made in the our next 10-minute session, or hopefully in the Q&A. But let's back up for just a minute and ask, how is it that we know the Earth is this old? It's not just biologists that are telling us this. It's not just geologists. It's scientists in every major field, that all of them work independently through different lines of evidence that point to a picture of an ancient Earth and an even older universe. Physics, chemistry, astronomy, geology, paleontology, biology, anthropology, every major branch of science points to an old universe model. So we're not talking about one or two key points that need to be wrong. We're talking about the whole of the scientific method that needs to be wrong. So let's go briefly over some of the different ways that these different scientists come up with these numbers. We can go to the next slide. First of all, astronomers notice that the universe is very large. The sun is only about 8 light minutes away from us. It takes light traveling at 186 million miles per second, about 8 minutes to get from the sun to here. But the universe itself is billions of light years long. Billions of light years wide. So if the universe is, in fact, 10,000 years old, not only would those stars billions of light years away, not only would it be bizarre for things to be that far separated in a universe that's only a few thousand years old, but we would certainly not be able to see them. If a star is created, or a star comes into existence 10,000 years ago, and it's more than 10,000 light years away, we can't see it. And yet, we know that there are stars billions of light years away from us. We can see them. And we wonder, was the universe created in such a way 10,000 years ago that not only are these stars billions of light years away, but light from them was created in transit already on the way here? The way it would have looked billions of years ago when the light that we now see would have been emitted. So astronomers tell us that, they look at that. Astronomers also look at the distribution of matter in the universe. We know how different atoms are created. We know through nuclear fission that happens in stars. We know the nuclear processes of the ways that atoms like helium and hydrogen and heavier elements like carbon and uranium are created. We know the way that these molecules, the way that these atoms are created. And we can build models to say what types of stars, when they're burning, what types of stars, when they explode, distribute different types of atoms in the way that they do. And we can look at the distribution of atoms around the universe and say, this can only happen if a certain number of generations of stars have already passed. These types of stars were around, they burned out, they exploded, the gas from those gathered into these types of stars, they created new, heavier elements, and they exploded. And in order to get the distribution of atoms that we see around the universe, and all of the distribution of the different types, the different elements that we see on this planet, we can't have only one generation of stars preceding the formation of the Earth. Several generations of stars, very different types of stars, have to happen. So we can look at that and say, the distribution of atoms as we see it in the universe doesn't make sense in a young Earth, in a young universe model. We can go to the next point. Nuclear chemistry looks at atomic decay rates and says we can measure the different decay rates of different elements. Different elements decay at different rates, some having half-lives in the millions of seconds, and some having half-lives in the hundreds of millions of years. And we can look at the patterns of these decay rates and the amount that we measure these elements or these different isotopes in the universe, and we can say, this doesn't make sense in a young universe model. But it makes sense in a model of the universe that's billions, specifically somewhere around 14 billion years old. Next slide. Physicists look at the expansion rate of the universe. Not only is the universe expanding, we had the Big Bang, the formation of the universe, it's expanding. Not only is it expanding, but it's accelerating as it goes. So the stars in the galaxies that are more distant from us are moving away faster than the galaxies that are closer to us. And when we run the math on this, something interesting happens. The galaxies that are closer to us, when we hit the rewind button on the acceleration rate, and we say, what happens if we look at what's going on now and rewind? The stars that we look at in the galaxies in that direction, the galaxies we look at in that direction, the galaxies that are a few dozen light years away or a few hundred light years away, the galaxies that are billions of light years away, when we hit the rewind button, all of them converge at a single point about 14 billion years ago. That's an interesting coincidence. This is another line of evidence completely separate from the other ones we've looked at that point to an old universe model. Geologists look at rock strata, they look at continental drift, and they say these formations, these properties of the Earth that we look at, make sense in a model that's billions of years old. Now, like I said, I'm going to avoid the temptation to respond directly to what was said a moment ago. We might respond to some of those in the 10 minutes that we get next, or ask us if we skip it, and ask us in the Q&A. But it's not just the different rock strata that geologists still accept, and is still universally talked about in geology as a method of dating the different layers of the Earth. But we can also look at the continental drift, and we can see very clearly the different plates on the planet that are moving apart. And if we hit the rewind button, we can see the continents fit very nicely together. This fits with what we know about the geographic distribution of life. And we can rewind several hundred million years and say, a couple hundred million years ago, there was one giant continent. These observations make sense if, in fact, the Earth is at least a few hundred million years old. These observations don't make sense if it's only a few thousand years old, because we have to wonder why it was made to look like a few hundred million years ago it was all one continent. After geologists, after geology, you can go on to the next slide, paleontologists, which is a relatively new field of science, but paleontologists look at fossils that we find fossilized, not just bones, but we can find whole organisms. Sometimes they get fossilized. If you've seen Jurassic Park, you know the concept of small bugs and animals getting caught in fossilized tree sap. And we can actually pull DNA from them, we can get skin samples. We can look at all different methods of dating and looking at these fossilized samples. And that points to a model of the Earth that is at least hundreds of millions of years old. In fact, we can say at least a couple billion years old in the fossil record. After paleontology, we look at biology. Biology points to a picture of common ancestry for all of the life on this planet. That common ancestry, that evidence, the same type of evidence that's used in court to prove paternal DNA tests, to prove who is the parent of a child, or to prove that this DNA matches the DNA of the suspect that we're looking at. The same ways that we analyze DNA there, we can look at and analyze DNA of different species and ask the question, how closely related are they? And this tree of relatedness that we get from the field of biology doesn't make sense in a young Earth model, but it does make sense in an old Earth model. I'll skip over the biographic distribution, go back one more real quick. Anthropology. Anthropologists look at the linguistic, cultural, and artistic developments that we see throughout the different cultures, the different groups of people on the planet, and they say this doesn't make sense if the Earth is only 6,000 to 10,000 years old. It doesn't make sense. We know that dogs were domesticated at least 15,000 years ago, and that domesticating of dogs is a relatively recent advancement in the culture of human beings. So we can look at all of the different fields of science, you can go to the next slide, that don't just point to a different picture than our friends over here are painting. They all point to the same picture of an ancient Earth, 4.5 billion years old, and a universe that's much older than that. So with that in mind, as I mentioned before, it's not just one or two points that need to be wrong. They're not saying we need to reanalyze this and this, these 3 or 4 lines of evidence. They're proposing we overthrow all of the major branches of science in order to come to the conclusion that the Earth is only thousands of years old. Now think about this for a moment. Think about what science has done just in the last 100 years. In the last 100 years alone, we've managed to